Alright, to edit off that for 10 seconds. Okay, so I was just playing around having a look at defining functions in different ways. Let me just try and back up. So here's the first one. So defining a function double that returns an integer, and I'm defining it as an SQL function, and just to prove that functions in Postgres are just strings, I've actually defined it by giving a string containing the SQL statement. If I type enter, it's going to fail because this function already exists. What's giving me a syntax error? Gee. Because, alright, there was something lingering from that \EF. But in any case, so that's how I can define a function, and once I've defined it, I could use it like this. And it should give me the result 10. So it takes the value 10, feeds it in as the parameter n, multiplies n by 2, and the result of the function is whatever comes out of that last SQL statement, which is the one and only SQL statement in the function. So you don't have to explicitly say return like you do in C, for example. If you want to edit a function once you've defined it, there's a \EF will drop you into the editor. In this case, I hadn't actually specified which function I wanted to edit, so that's not particularly useful. Let's try editing the function double. Right, so it drops me into the editor, and this time we get quite a different looking syntax, but it's actually exactly the same thing. We can see, remember I think I mentioned that all objects in a Postgres database exist in a schema. There's a default schema called public, and most of the time we're using the public schema, so we just don't mention it at all. Everything is assumed to be part of the public schema. Create or replace function returns an integer. You can see that you can define the language either before the function definition or after the function definition. Here is the function definition, that bit in there, and now we've got this weird stuff around the outside, dollar function, dollar function, dollar. They're really just quotes. They're extravagant looking quotes, but that's all they are. And I can, if I wanted to, I could replace them. It'd be nice to put some space, but I could do it like that if I wanted to. But now I realise why this thing isn't finishing off the command. So that would just redefine the function. Notice down here, very subtle, the prompt is different. That means that Postgres is waiting for me to finish off that command. In other words, it hasn't done the create or replace yet, and it won't do it unless I do semicolon, and then it recreates the function. So I can go back and select _2, and that should tell me 4. I noticed before that I can also do something like this. So I'm using a call to a function that's going to produce a single value in the context where a table would normally occur. Now Postgres is a little bit flexible. If it sees a table that has a single column and a single row, you can either treat that as a table with a single row and a single column, or you can treat it as the value in that row column. So here it's going to produce something that looks like a table with a single row and a single column, like we had here. Let's have a look at triangle. So when it pings up a function inside the function editor, it always surrounds it by these quotes. If you want, you can change the tag to whatever. So I can do that. As long as the two quotes at either end of the function match, then it's fine. And if I really wanted to, I could even replace them by quotes. So they'll just create a triple function which multiplies by 3 if you're looking carefully at the function definition. So like that. Right, so that's defining very simple functions. Here we got slightly more complex function, not much, but one thing about the function is it's using a more complicated query and it's feeding the value into here. So when you're defining functions in Postgres, you can either give names to the parameters, or you can not give names to the parameters, you just give the type as a parameter, which is what I've done here. If you don't give a name to the parameter, then you have to refer to it by its position in the parameter list. So that's basically just saying the first parameter. Alright, what else we got? Oh yeah, so here's an example of a function that returns a table, i.e. a set of bars, where bars is the type of a table, or bars is a table, but remember when you create a table you also get a type, that's the type of the tuples in that table. So this is basically saying return a set of tuples where the tuples are the same type of tuples as you find in the bars table. In other words, they have those 3 attributes. So once again, we're defining a simple function, in this case because we're returning multiple values because we're using a select query from a real table and we're not forcing it to be a single result. Then we can get a table back from the function. Alright, so let's continue. Alright, so remember that last time we had in question 19 that we solved yesterday, we had nested queries, we had correlated subqueries, and the whole thing was a little bit messy. We can make it a lot simpler if we define an SQL function. So, I mean, there may be a nested query involved, but it's hidden behind the function interface. So we can solve our problem by doing this, and this is a little bit more obvious than the solution that we had yesterday. So we want to define this function here. So it's a function that takes the name of a bar and finds the minimum price beer at that bar, and it just gives us the price. So that's pretty straightforward. And have I got it here? Yeah, I do. So that function there would do that. And so we want the lowest price at a particular bar. So select the minimum price from the sales table, where we're only interested in tuples that belong to this particular bar. Now, you may notice that I put an underscore in front of the parameter name. What do you suppose would happen if I didn't? Postgres is going to get confused. It sees bar and it sees bar, and in fact the way it's going to interpret it is as the bar associated with the cells table. So in fact, this is going to match everything. It's not just going to match the bar that we fed in. So this should end up giving me the overall minimum price. Let's just check that. So if we want to load definitions from a file, you can do it from inside PSQL by using \i, which is kind of like hash include that. Oh, cannot change the number. Interesting. Alright. So I'll have to drop that function. So here's how you get rid of a function. And notice that you have to specify the type of the parameter, because since you can overload function names, so you can have multiple functions with the same names but different parameters, you need to say which particular one you're talking about, even when you've only got one function with that particular name. Right, so let's load that up again, and then let's try and find the lowest price at So it says the lowest price at the Coogee Bay Hotel is 50 cents. If we were to actually look up the tuples, see that there's nothing in the Coogee Bay Hotel that costs just 50 cents. Okay, so what that function's done is it's basically it's done that. It's found the absolute minimum price, and the reason it's done that is because that where clause succeeds for every that where clause succeeds for everything, because it can't distinguish that bar, which is from here, from that bar, which is from here. So that can be the source of some difficult to spot errors when you're writing a PLpgSQL function. I mean, here it's kind of obvious, but if you've got a much larger function and you forget that one of your tables has an attribute called x, and you thought x was a great name for a function parameter, the function's going to get totally confused by that. So the way I resolve that problem is just all my parameters, and I'll forget to do this during the lecture, but all the parameters just stick an underscore at the start. So that's a perfectly valid identifier, and that will resolve that ambiguity. And to make that load, so if we look at Coogee Bay Hotel, the lowest price at the Coogee Bay Hotel is $2.25. Right, so we can check that with the new version of the function, make sure it's working properly. So I'll need to drop the old function and load up the new version. So select the lowest price, using the lowest price, that function from Coogee Bay Hotel, which I could have pasted in. $2.25. So it's actually found the right one. Up here, when that parameter name matched the attribute name, it found the lowest price overall. Here it's actually found the correct price. So that's one thing I was going to say about PLpgSQL gotchas. You've got to be a little bit careful about some things. Alright, so a function that returns a set of tuples kind of has the same external appearance as a view. One difference is that a function can actually take parameters, whereas views can't. So here we could produce a list of employees, which is basically going to give back a name and an address like that, and we can use that by saying select from emp list, and that'll give us our employees. If I wanted to do that via an SQL function, the guts of it would be the same as what we had in the view, but there's a lot more stuff that needs to be wrapped around. For one thing, we don't have an appropriate tuple type before we start, so we actually have to create one. So we can say, hey, I want a tuple type called emp record, which has got two text fields, one called name, one called address, and then I can return a set of tuples of that type. So to some extent, the view kind of does that implicitly. It works it out from what you've done in the select statement that defines the view. So this select statement, we know that we're concatenating two text fields, so we know that the result type of the first thing coming back from here is text, and similarly for this one we know they're both text. So we know that both these attributes are going to be of type text. But here we have to tell the system so that we can define an employee record there. Yeah, so a little bit of difference. So the interesting thing with functions, so it might look like there's a lot more effort to do this than there is to just define a view. But if you really wanted to, you can actually have parameters here, and you can say which particular set of employees you're interested in. Whereas if you're doing it with a view, you could do that. You'd need to add a where clause at the end here to filter out just the employees that you actually wanted. Right, so let's have a look at PLpgSQL. So that was all just SQL functions. So all of those functions are going to be stored in the database, and you can find out what functions you've got stored in the database by doing that. So I've got double, triple, lowest price at max price. If you want to look at the definition of a function, I was sure there was a way to do it with a \d, but I can't remember what it is. But certainly you can always find what a function looks like by doing that. And there's your definition, and it's an SQL function. And like I said, these things, they're quotes, and we've got a matching quote. So if you've ever done shell programming, you know about less than, and you put a tag, and then whatever else you put after that is fed into the command that had the less than, and you finish the input by putting the same tag at the other end. So it's a similar kind of idea. Alright, let me see. So what can PLpgSQL buy us? By us, not by us. So we can now do more complex constraint checking if we write PLpgSQL functions and we embed them in the system in an appropriate place, basically at the end of a trigger. We can do more complex query evaluation. In theory, we can do recursive queries directly in SQL, but you can do recursive queries maybe in a way that's a little bit more familiar in PLpgSQL. If you need to do complex computation of column values, etc., and you get a little bit more control what the results end up looking like. So once again, here's create or replace function, list of parameters, returns a particular return type, and $, or quotes around the whole function definition. Extra things that you have to do in PLpgSQL that you don't have to do for an SQL function is this stuff. So you have to have begin end around the body of the function, and if you want to have some local variable declarations, you can define it like that. So declare a bunch of variable declarations, then begin, then the code, then end, and that's your entire PLpgSQL function. And as it says down here, it's done as a single string. So here's a very simple PLpgSQL function. It's basically just that double function redone as PLpgSQL, and you say, oh, that's a lot more complicated than the SQL function, and that's true, but it was intended to be simple just to show mechanisms involved. So we've got a function called double, takes in an integer value, returns an integer result. Just for fun, I declared a local variable, totally unnecessary. We could have implemented the body of a function like that, but hey, I can use this example to show you the assignment operator. So it's not just a single equals like every other language that we use these days. It's colon equals, which is a syntax for assignment that's been around forever. Are there any modern languages that use that syntax for assignments? No, why are you laughing? You find this whole thing amusing, using that for assignment. Anyway, it's kind of handy because then it looks different to a single equals, which is the equality operator in SQL. Alright. So we assign the value of 2 times the input parameter to the local variable called result, and then we return that value. So if you want to return a value from a function, you have to put a return statement with the value. So that's a little bit like C, and that's about the only thing that's like C. And yeah, if you don't want to write all this guff, you can just do that. And notice you can put it all on one line if you want to, and it works just fine. Now, one reason why we have these special quotes around function bodies is because the entire function is a string. And if you want to have nested quotes in the string, then that makes things a little bit complicated. So what I'm writing here is a function that takes 2 strings as input, and you don't write them with double quotes in SQL. This is the conceptual level, so a string containing a single character A, string containing a single character B, and the output from the function is a string that contains the first string followed by a single quote followed by the second string. Not useful at all, but it illustrates an interesting property of PLpgSQL functions. Oh, notice the other thing, I've stuck quotes around PLpgSQL down here, that's optional. Alright, so this function takes in 2 text variable or 2 text values, first one called x, second one called y, and returns another text value. Here we're defining a local variable, once again not totally necessary, and then we're concatenating x and y with a single quote in between. Alright, so we have to write 4 quotes because we want to have a string containing a single quote, and if we want to put a single quote in a string, we have to double it up. So that will give us a single quote. And notice here that we've used these fancy quotes around the outside, and we've given a different name. And I don't know why I called it ad, I probably should call it cat or something. But anyway. And this point I've made more than once already, don't do it, otherwise you're going to confuse yourself. And that strategy of starting all parameter names with an underscore is something that I've violated already right here by not doing that. But if you're not accessing the database at all, then that's not a problem, because you're not dealing with any attributes that you can get confused with the name. Right, so that's how you do things these days. Let's have a look at how you used to do things before they introduced these special quotes. So the whole thing was a string. We didn't have parameter names. So this is, we're talking 3 or 4 versions of Postgres ago. So if you wanted to have a name for a parameter, you had to use this syntax here. So the identifier X is really just a replacement for $1, which is the first parameter. Y is another name for $2. And then if you want to concatenate them, now we have a problem, because the body is contained inside a single quoted string. So if you want to have a string that consists of a single quote, you have to write that, which is cute. I have seen 16 single quotes in a row in a Postgres function definition, and now you can see why they wanted to use something other than a single quote around function bodies. So that's amusing. So that effectively evaluates to a single quote, a string containing a single quote. Alright, so things are a little bit better these days. The function definitions look a little bit more natural than these ones. Alright, so remembering back that we had this problem, we wanted to withdraw money. I showed you an example of how you might write that using the SQL standard stored procedure language. Here's how you do it in PLpgSQL. So there's a couple of new things involved here. The function header is pretty much the same. So we've got a text parameter and an integer parameter, and we return a text result. You can declare a local variable, but if you want to, remember in the previous example we said set bell equals the output of the select statement. In PLpgSQL, this is the way you extract a value from a select statement. So you do a select into and then give it a local variable. So whatever value you selected ends up being stored here. Once again, we've still got that issue of what happens if this query here fails and it doesn't give us any results. Then what actually happens is this ends up with the value null, so that's alright. What happens if account number was ambiguous and there were multiple accounts with the same account number, then you get multiple results coming back. The first of those results ends up being stored in here. That's not at all useful, because the order of tuples, unless you specify some sort of ordering criteria, the order of tuples that you get back from Postgres looks a little bit random, and it's really related to the tuple that was most recently updated. It tends to be the one that comes out last. So effectively treat the ordering that that PostgreSQL gives you as random order on tuples, unless you explicitly specify order by. Alright, in any case, so we got the balance from this particular account, stored it in this local variable, checked whether we had enough funds. If we didn't, we return that result. Then we do that select statement, we do that update statement, then we do another select to grab the new balance, once again select into, and that's what we return. And that also would fail, and I think what you need to do is cast that to a text result. Right, let me see, is there anything else remarkable there? No, so we've got the same syntax. So the syntax is a little bit similar to the standard, but beautifully done, thank you, Postgres. Not quite the same. They were there first, so they can, I don't know, claim prior ownership. The other thing about PLpgSQL syntax, if you ever have to deal with Oracle, Oracle has a stored procedure language called PLsQL, which is very similar to Postgres' stored procedure language, so it's pretty easy to move from Postgres to Oracle. It's not identical, but it's very close. Alright, so just to warn you about a couple of things. One thing that you're going to find annoying when you're trying to debug your PLpgSQL functions is you don't have any debugging printfs and you don't have GDB. So there's no I/O. So the whole point of these functions is that they can get stuff from the database, they can compute results, and they return those results. So on the way, you don't need to print anything. At least that's what Postgres thought. However, there is one way you can get some information out of the system, and it's to use raise, which is effectively raising an exception. But if you raise a notice exception, that's not as fatal. But what it does is it sticks a message into the Postgres log file. So you can stick raise notices all through your PLpgSQL code. You can run the function. If it doesn't give you the right result, you go and look at the log file and you'll get some kind of debugging trace. The other slightly annoying thing about PLpgSQL is you write the function, you load it into the database, it says create function, so you think everything's all right, but it hasn't done any syntax checking. All it's done is stick the string into the database. And so what it sticks the string, the function name, information about the parameters, and information about what language the string, the function body is written in. When you come to execute the function, it goes and fetches that string and then tries to interpret it relative to the language that you specify. And so if there's something wrong, you won't find out till you try to run the function that there's some syntax error, which can be slightly annoying as well. Error messages are a lot better these days than they used to be a few versions of Postgres ago. So that's okay. Functions being defined as strings can be a little bit confusing as well because the lexical scope. So like I said, that the parameter names that you define in the create or replace are in some sense in a different place to the body of the function. You can use them in the body of the function, but they're different. I'm trying to think of a good example, but I can't off the top of my head. But that can potentially be slightly confusing. And the other really silly thing to do, which I've done before and got stumped trying to work out what was wrong with my function, was to have a parameter or a variable with the same name as one of the attributes I was manipulating. So a local variable x, and I was saying select x from some table, and it didn't really know what x I was talking about, and you can't even go select x into x and expect that to work correctly. So basically debugging PLpgSQL functions can be a little bit tricky at times. Alright, so what kind of data can we define in PLpgSQL functions? You can use all the standard data types, varchar, 20, text, date, number, whatever. You can use, if you go and define your own data types, I assume this works for domains, you can use them as well. when you're accessing the database from PLpgSQL functions, there's a special type that you can use, which basically says, here I've got an object, let's call it tup, which is a record. I'm not going to tell you anything about tup just yet. I'm going to use tup in the context of a query, and depending what the results of that query look like and what the tuple types of the results of that query are, that's the type that this record is going to take on. Right, so it doesn't get bound to the exact data type until you run a query and you can see what the types are. If you want, you can base your variables on the type of an existing table. This %row type used to be required, nowadays it's optional, so you can just write, I want a variable of type branches, and that will work. If you can't be bothered working out what the type of a particular attribute is, then you can get the system to work it out for you. That is required if you want to do things that way. Might be better if you knew what the type was and then to find the variable to be of that type. And there's also a special type for interacting with SQL. We generally don't define explicit cursor variables. They're usually implicit in the context of a for loop that works off a query. What have we got? Yeah, so employee could be defined either like that or just as the word employees. Alright, so what control structures do we have? We have assignment, either using this colon equals assignment operator, so you can evaluate an expression, assign the value to the variable, or you can use a select statement and grab the value of one of the attributes in the select clause and stick it into a variable. We got if, so we've got if, else if, else if, else if, and then else and if, and various flavours of loops. So you can have an infinite loop if you really want to do that, or while. You can have a while loop. So the syntax is a little bit weird looking, so that's required, that keyword, and that's effectively the same as an open curly brace in a C while loop. This is extremely useful, so you can run a query and have a variable, and each of the results of the query in turn, each of the tuples, is going to be assigned to this record variable. So typically that record variable would be some kind of tuple type, and the query returns results of some kind of tuple type, and each result, each tuple that's returned is assigned one at a time to this thing, and then we execute the body of the loop. And then we get the next tuple, execute the body of the loop again, with that having the appropriate value, get the next tuple, until the query is finished. And you can also have for loops that iterate over a range of integer values. Select into is a little bit more complicated than what I've described so far. If you've got a select statement that has multiple things coming back, so you do select star from biz, for example, you get the name of the biz, the name of the manufacturer, so you're getting back two values. You can actually, if you have two variables here, then you can get both of those variables set at once. So each of these expressions is the kind of expression that you'd have in the select statement. Initially, it has a value and a type. If the type of the result matches the type of that variable or can be cast appropriately, then the value of this expression will be assigned to that variable. Then we look at the second expression. What value does it have? What type does it have? check the types are matching and assign the value. And of course, you've got to have the same number of variables as you've got expressions in the select clause. So if you go select A, comma B, comma C from some table, then you've got to have X and Y and Z if you want to store the values there. Yeah, alright, so that's slightly useful. So here's an example. So selecting a single attribute into a single variable. If I wanted to say, I don't know, select name, comma, price into, then I'd have to say item, comma, cost. And having extracted that value, then I've got a value in a variable and I can use it like any old variable from then on. Also, for some weird reason, but don't bother using this, Postgres will let you write the select into that way around rather than this way around, which makes a lot more sense. This way around makes a lot more sense if you've got multiple expressions in your select clause. Let me see what I've got here. Aha, yeah. Another thing you can do, if you're selecting a result which is effectively a whole tuple, which is basically what the asterisk means, you can store the entire result into a tuple of the appropriate type. So here we're defining empt to be a tuple of the type that the employees table uses. If we're selecting from the employees table, and we're getting all of the attributes from this particular tuple in the employees table, then we've effectively got a value of that type, which we could then assign to this variable here. Okay. So, like I said before, you don't actually need the %row type. You can just say emp is a variable of type employees. If I was extracting just some information about the employee, like I've done down here, name, comma, salary, into, I couldn't select that into an emp because the types are different. So here we'd have potentially, 4 or 5 different attributes as part of the employees table, and this record here will have the same 4 or 5 attributes. If I just select these, I can't select them into emp because there's only 2 values. I'm trying to stick them into a tuple with 5 slots, if you like. Here we can just grab the name and the salary and stick it into these 2 variables here. And once again, we expect the types to match up. So the name in the employees table is going to be of type text, and pay is going to be a real value, which I think you can use in Postgres, but normally we use float. Let me see, oh yeah, so the only issue is what happens if we're selecting and we don't get any results back. So this never gets a value that we can store into here, so B ends up with a value null. If the selection returns multiple results, multiple values for A, then the first one gets stored in the variable B. Generally, you'd be interested in checking whether you've actually got a value back, so when you do select into. So one way you could do that is to look for the value of B being null. Another way of doing that is to use a special variable, which is a kind of a global variable, which is set in PLpgSQL functions. Every time you do a query, it'll be set to true if you get back at least one result, and it'll be set to false if you don't get any results. So you can use it kind of like this. So you try to get a value from R and store it in B. If the where clause doesn't match any of the tuples in R, then found will be set to false, not found will be set to true, and you can handle it that way. And I reckon that's the point to stop. Yeah, so I'll continue on this next week.